Hello, my name is Todd Baginski. I'm an 11-time SharePoint MVP and a partner and CTO at my company Canviz. In this training module, I'm going to show you how to get started with the SharePoint framework. This is section 4 of the Getting Started with the SharePoint Framework training module. In this section, I will discuss the basic React implementation for building client-side web parts. In this section, we're going to discuss component design, splitting UIs, and designing flows in communications. Here are the steps you need to design and build React-based web parts. It's a three-part process. First, you'll do your component design, then you'll split UIs, then you'll design your flows and communications between all those different pieces. The key feature of React is composition of components. Components written by different people should work well together. Add functionality to a component without causing rippling changes throughout the code base. For example, it should be possible to introduce some local state into a component without changing any of the components using it. Similarly, it should be possible to add some initialization and teardown code to any component when necessary. There is nothing bad about using state or lifecycle hooks in components, but like any powerful features, they should be used in moderation. In React, components describe any composable behavior, and this includes rendering, lifecycle, and state. This process of building and thinking in React can be found on the facebook.github.io/react/docs website. Imagine that we have already had a JSON API and a mock from our designer, like the design in this slide. Our JSON API returns some data that looks like the data in this slide. This is what we're going to talk through on how to build in React, how we could build this component from this data. The first thing that you'll want to do is draw boxes around every component and subcomponent in the mock and give them all names. If you're working with the designer, they may already have done this, so go talk to them. Their Photoshop layer names may end up being the names of your React components. But how do you know what should be its own component? Well, you just use the same techniques for deciding if you should create a new function or object. One such technique is the single responsibility principle. That is, a component should ideally only do one thing. If it ends up growing, it should be decomposed into smaller subcomponents. Since you're often displaying a JSON data model to a user, you'll find that if your model was built correctly, your UI, and therefore your component structure too, will map nicely. That's because UI and data models tend to adhere to the same information architecture, which means the work of separating your UI into components is often trivial. Just break the component up into components that represent exactly one piece of your data model. You'll see here that there are 5 components in this simple app. We've italicized the data each component represents. We have the filterable product table in orange. This contains the entirety of the example. The search bar in blue receives all user input. The product table in green displays and filters the data collection based on the user's input. The product category row in turquoise displays a heading for each category. The product row in red displays a row for each product. If you look at product table, you'll see that the table header containing the name and price labels isn't its own component. This is a matter of personal preference, and there's an argument to be made either way. For this example, we left it as part of the product table because it's part of the rendering of the data collection, which is the product table's responsibility. However, if this header grows to be complex, for example, if we were to add affordances for sorting, it would certainly make sense to make it its own product table header component. Now that we've identified the components in our mock, we need to arrange them into a hierarchy. This is very easy to do. Components that appear within another component in the mock should appear as a child in the hierarchy. You can see how this has been done as these things have been laid out and indented on this slide. After you break things in the UI into a component hierarchy, the next thing to do is build a static version of it in React. The easiest way is to build a version that takes your data model and renders the UI but has no interactivity associated with it. It's best to decouple these processes because building a static version requires a lot of typing and no thinking, and adding interactivity requires a lot of thinking and not a lot of typing. We'll see why. To build a static version of your app that renders your data model, you want to build components that reuse other components and pass data using props. Props are a way of passing data from parent to child. If you're familiar with the concept of state, don't use state at all to build this static version. State is reserved only for an activity, that is, data that changes over time. Since this is a static version of the app, we don't need it. You can build top-down or bottom-up. It's up to you. That is, you can either start with building the components higher up in the hierarchy, for example, in this case, starting with the filterable product table, or with the ones lower in it, like the product row. In simpler examples, it's usually easier to go top-down, and on larger projects, it's easier to go bottom-up and write tests as you build. At the end of this step, you'll have a library of reusable components that render your data model. The components will have only render methods since this is a static version of your app. The component at the top of this hierarchy, the filterable product table, will take your data model as a prop. If you make a change to your underlying data model and call React DOM.render again, the UI will be updated accordingly. It's easy to see how your UI is updated and where to make changes since there's nothing complicated going on at this point. React's one-way data flow, also called one-way binding, keeps everything modular and fast. After you've built your static version in React, the next piece of the puzzle is to identify the minimal but complete representation of your UI state. To make your UI interactive, you need to be able to trigger changes to your underlying data model. React makes this easy with state. To build your app correctly, you first need to think of the minimal set of mutable state that your app has. The key here is the DRY. This is don't repeat yourself. Figure out the absolute minimal representation of the state your application needs and compute everything else as you need on demand. For example, if you're building a to-do list, let's just keep an array of the to-do items around, but don't keep a separate state variable for the count. Instead, when you want to render the to-do count, simply take the length of the to-do items array. Think of all the pieces of data in our example application. We have the original list of products, the search text the user entered, the value of the checkbox, the filtered list of products. Let's go through each one and figure out which one is state. Simply ask 3 questions about each piece of data. Is it passed in from a parent via props? If so, it probably isn't state. Does it remain unchanged over time? If so, it probably isn't state. Can you compute it based on any other state or props in your component? If so, again, it isn't state. The original list of products is passed in as props, so that's not state. The search text and checkbox seem to be state since they change over time and can't be computed from anything. And finally, the filtered list of products isn't state because it can be computed by combining the original list of products with the search text and the value of the checkbox. So finally, that means our state is the search text the user has entered and the value of the checkbox. Now that we've identified what our state is, we need to identify where that state should live. In this case, we're going to be identifying actually the component which mutates or owns that state. Keep in mind, React is all about one-way data flow down the component hierarchy. It may not be immediately clear which component should own what state. This is often the most challenging part for newcomers to understand. So follow these steps to figure it out. For each piece of state in your application, identify every component that renders something based on that state. Find a common owner component, a single component above all the components that need the state in the hierarchy. Either the common owner or another component higher up in the hierarchy should own the state. If you can't find a component where it makes sense to own the state, create a new component simply for holding the state and add it somewhere in the hierarchy above the common owner component. Let's run through this strategy for this application. The product table needs to filter the product list based on state, and the search bar needs to display the search text in checked state. The common owner component is the filterable product table. It conceptually makes sense for the filter text and checked value to live in filter product table. So we decided that our state lives in the filterable product table. First, we add an instance property, this.state equals filter text, in stock only, false, to the filterable product table's constructor to reflect the initial state of the application. Then, pass the filter text and in stock only to product table and search bar as a prop. Finally, use these props to filter the rows in product table and set the values of the form fields in search bar. You can start seeing how your application will behave now. Set filter text to ball and refresh your app. You'll see the data table is updated correctly. At this point, we build an app that renders correctly as a function of props and state flowing down the hierarchy. Now it's time to support data flowing in the other way. The components deep in the hierarchy need to update the state in the filterable product table. React makes this data flow explicit to make it easy to understand how your program works, but it does require a little more typing than a traditional two-way data binding. If you try to type or check the box in the current version of the example, you'll see that the React ignores your input. This is intentional, as the value prop of the input to always be equal to the state passed in the filterable product table. So think about what you need to happen. We want to make sure that whenever the user changes the form, we update the state to reflect the user input. Since components should only update their own state, filterable product table will pass a callback to search bar that will fire whenever the state should be updated. We can use the onChange event on the inputs to be notified about it, and the callback passed by filterable product table will call setState and the app will be updated. Though this sounds complex, it's really just a few lines of code, and it's really explicit how your data is flowing throughout the app. Now I'm going to show you a demo of a basic React to-do web part that uses components and state. The web part that I'm showing you in this demo is also available on the internet. It is found in the GitHub repository called sp-dev-fx-webparts. This is the only sample in the series of training videos that's not actually part of the SharePoint Framework content repo where all these other samples are found. So here you can see this repo, and inside of this repo I'm using the sample called react-to-do-basic. The to-do basic sample web part shows many different framework features from SharePoint Framework that'll help you build web parts with really good user experiences, but it also has the coding pattern and practices for the React-based web parts that we're talking about in this training module. There's many different patterns you can choose from to build your React-based app, and this web part uses the container component approach. Here you can see what this container component approach looks like in the reactpatterns.com website. I think the key thing here to understand is a container does data fetching and then renders its corresponding subcomponent. That's it. So you can see on this site an example of a reusable comment list component, and then you can see below that how the component is responsible for fetching data and then rendering the stateless comment list component. So this particular web part that we're going to look through now, the React to-do list basic, takes that container component approach. Let's take a look at what that code looks like. So here's the actual web part. I have it opened up in Visual Studio Code here. And notice I am looking at, if I minimize all the components, I look at the basic to-do web part class to start out. And you'll notice I have several different components within this that take this container component approach. So here's my to-do container component. Then I have the to-do form component, to-do list, and to-do list item. For each component we have the component file, which is the .tsx file like this. This is where you actually code your implementation, and as you can see here, HTML creates your user interface for that component. We also have the properties interface. So here's the properties interface for this component, which allows it to pass properties to other components. We also have the state interface right here. So this holds the state for this web part component. This particular React component, the to-do container, as you can see, exposes a variable called to-do items, which is an array of to-do item. We also have the SCSS files inside of here, which define our CSS for our particular component on a per component basis. So you can see here that each one of these web parts follows the same pattern. Notice some components have state, like the container and the form. However, the to-do list and the to-do list item do not have state because they don't need to maintain it. If we take a look here at the base web part class, to-do web part right here, you can see, and I'll point out how some of these components are used. First, notice that the container component right here is imported, and we've also imported the interface to the properties for the container component as well. These are the only two React components that we reference in this class. If we take a look at our render method here, this is where the actual React element is created for the container component. So React element right here takes in the interface to our to-do container for its properties, and then we call react.createElement, and we create an instance of that to-do container. We pass in the data provider, which is a web part property set on this base class, which says is it going to use the mock data provider or the SharePoint HTTP provider. If you've watched the previous modules I've done on this, you'll see how you can make a data provider be a mock data provider or a real one that's talking to SharePoint, depending on if you're running inside or outside of SharePoint Workbench or a SharePoint web page. We also have the display mode that we're passing into the container and the open property pane as well. So once we create that container component there, then we can set it equal to a local property to represent that component and actually render it out to the DOM. If we go inside of our container component itself now, here you can see that this component imports its properties and its state from those two classes there so that it can use them. And then I think to really follow through with this what I've talked about is the approach on how you plug these components in, the render method really goes to show how that is done. So here we can see in the render method for our container component, what we have here is we're using some Office UI controls and fabric here on the different React components and things like that. But then here's our to-do form component, and here's our to-do list component. And you can see different properties are passed into these components, such as the state for the list, and when you complete a to-do item or delete it, what happens there. So this is an example of how this container component actually contains these two components in this React pattern. If we dig down into our other components here and take a look at the form, for example, you'll see in the render method here, I do not have any React components that are part of this form. So that shows me that this component does not have any subcomponents inside of it. If I look at the to-do list component, that was also part of our container component though, here you can see the to-do list component is rendered inside of it. So this is 3 deep and actually 4 deep in the hierarchy here. We start out with our base web part class, then we add the to-do container component to it, then we add the to-do list component, which is this class, and then the 4th level of our component is the to-do list item. And that represents each individual item in the list. So here's what that component looks like and how it renders these out. Notice that there are no more components being passed or used here to generate our user interface. So this is the bottom level component. Now I'm going to run this web part in local workbench, and you can see down here after I typed in gulp serve, this one is now being served up. And in just a moment, we'll have our SharePoint workbench available. There it is. So now I can add the web part and then go to configure it and pick a mock list. And now you can see actually what this web part looks like. So the form component is this text box and the add button. The list component is these collection of items here, and the list item component is each individual item in the list. This is a very simple web part where we can add in items and click add, and it will add them to the list. We can also do things like deleting them and removing them from the list. In the amount of time we have available in this video, I don't have time to walk through all of the different methods that affect this as you do these different actions, nor do I have time to discuss the plumbing between the properties on the right and the web part. But as I mentioned, if you just come to this sample here and download it, you can look at the code and you can also read through all of the different features inside of here and how they were implemented and how they make up this web part. In this section, we discussed component design, splitting UIs, and design flows and communications. You can learn more about SharePoint framework and all the things we've talked about here in the SharePoint Patterns and Practices. You can get to this via the URL aka.ms/SharePointPNP. There's a ton of code samples and solutions, reusable components, a lot of guidance documentation, and also monthly community calls that you can watch here to learn all about the SharePoint framework, SharePoint add-ins, Microsoft Graph, and Office 365 APIs.